Composition and empirical formula are going to be two of the specific ways that we describe compounds in this class. So the difference between percent composition and empirical formula is basically percent composition is about mass. It's the percent mass of a particular element in a compound. So the formula specifically is the mass of the element divided by the mass of the whole compound to get the percent composition. But an empirical formula is a ratio of the moles. So remember, the subscripts are representing the lowest ratio of moles of each type of element within the compound. And so if we said MXOY is a ratio that X over Y is the moles of M over the moles of Y. So it's a mole ratio. It's describing how many moles of each substance are in a mole of the compound. So one is a ratio of mass, the other is a ratio of moles. Basically, we are going to be converting, so if we're doing percent composition and we're going to empirical formula, we're really taking mass and converting it to moles. So I might give you the percent composition of a compound and say, what is its empirical formula? Another way it could go is I say, what is the percent composition of this compound? And I give you a chemical formula. So I have the empirical formula, and in that case we're really going from moles to mass. So we've talked about this type 2 conversion, mass to moles, moles to mass, involving the molar mass. That's the mainstay of these. But there's a couple little tricks along the way. So again, percent composition is ratio of mass. So we're going to convert the formula. We're going to say whatever the formula is telling me how many moles I have of each element, and I'm going to pretend if I have a mole of the whole formula, then those subscripts tell me how many moles of each element in the formula. I convert that from moles to mass to get each element's mass in that compound, and then I have to add up all the element masses to get the total compound mass. That's the molar mass of the whole compound. And then I need to divide the mass of each element divided by the mass of the total compound, multiply 100 to get percent. So let's look at how this is. So what is the percent composition of nitrogen and HNO3? If I have 1 mole of HNO3, then I have 1 mole of H, 1 mole of N, and 3 moles of O. I'm just using the subscripts of the H, the N, and the O. I multiply by their each element's molar mass. So for hydrogen it's 1.01, for nitrogen it's 14.0, for oxygen it's 16.0. I only went to one decimal place on the nitrogen and oxygen, but we'll get the idea. And now I want to add up the total. So if I had 1 gram of hydrogen and 14 grams of nitrogen and 48 grams of oxygen, that ends up being a total mass for the compound of 63 grams. Now, to get the percent composition, I'm going to take the element mass divided by the total mass. So 1.01 grams of hydrogen divided by 63, and then I multiply by 100 to get it into percent. That's 1.6% hydrogen. 14 grams divided by 63 grams times 100% is 22.2% nitrogen, and similarly 76% oxygen. Note that when I'm done, these should add up to 100. If I've done the percent composition of all the elements in the compound together, they should add up to 100% of the mass. So if I see 76 and 22, that would be 88.3. This is going to be I wonder if I made a mistake. That doesn't seem like it quite adds up. 76 and and 2 would be 78, 98.3, 98.9, 99.9. So it may be a tiny bit off due to rounding, but this is 99.9% instead of 100. So I'm in good shape.